Hello, everyone. Today, I would like to take you through a question they normally ask in chemistry at all times. The question may be one per year, or sometimes even there are two of them. It's a skill that you are required to have. So, normally they call it investigative skills. It accommodates two objectives or assessment criterion. That's criterion B and C. For today's video, I'm going to focus on criterion B, that part of designing an experiment. There are things you must know, there are skills you must have to be able to design an experiment. They may set this question when they are familiar to you, or sometimes they may not be familiar to you, but it doesn't matter. If you have the skill, then the information you need is within the question. So always take care to understand the stem of the question, which simply means what they say about the question. For example, this one here, if you're going to read it, there are things they say about it. Yeah, but I'm going to be jumping down to what I want to focus on. This part here, normally it's a minimum of 5 marks, 5, 6, 7, 8. So it's very important that you learn this skill. They will give you bullets. Now, when they say design an experiment, there are things normally they ask you about. There are normally 7 of them. So I'll take you through each one of them, and then you can become better at it. So number 1 is all about the independent variable. Independent variable. Among the questions, you must be able to identify it. After reading the stem or the beginning part of the question, within there, you can identify the independent variable. Sometimes they give you a hypothesis, and from it, you must identify the independent variable. That's the first thing about planning. Identify what is your independent variable. When this is done, talk about how you will manipulate it. Manipulate means that how are you going to deal with it? How are you going to be changing it and etc. So, in manipulating your independent variable, among the things you must say, please mention that you must use at a minimum, or you must use at least 5 specific values. For example, if it was the effect of temperature on rate of diffusion, now the temperature here is the independent variable. For an experiment, for to find out how does temperature affect diffusion, then you will have to use 5 different temperatures. Now, when we say being specific, that means choose the actual values. Now you can say I will use a temperature of 0 degrees. Maybe I will use 10 degrees. Maybe I will use 20 degrees. Maybe I will use 30. I will use 40 degrees. So you discover that you are now being specific. You pick out the actual values you will use. Sometimes they are values, sometimes they are words, but depending on the question, use at least 5 independent variables in your experiment. Say, I will use 5 independent variables like at 0 degrees, at 10 degrees, at 20, and etc. The other thing you notice, if they are values, please have an interval. Mine is an interval of guess. That's right. It's an interval of 10, 10. You can use 5. It depends on what you want. But we should have an interval. I'm not saying 0, 5, again 20. No, you won't get that mark. The other thing you must say for the experiment, you'll be repeating it, or you'll be carrying out 3 trials. 3 trials. That means repeating the experiment at the same independent variable. Maybe at 0, You repeat it 3 times. So ask yourself, why do you repeat 3 times? The answer is simple: to get sufficient data. They ask you why you do it, to get enough data. When you ask many people, then you are likely to the results that what you are inquiring about. If everyone says the same thing, then probably you are more likely to be correct and more valid. If you ask only one person, you can be biased. There could be an error. That's why you must carry out 3 trials or 3 experiments at each individual value you have chosen. But don't stop there. That means that at every trial, you will get a value. So you must tell us you will be getting or you'll be calculating an average. You will be calculating an average. And the first part is fully done. Identify, tell us what it is. Show how you manipulate it by telling us that you'll be using 5 values and specify what they are. Then you say at each value, you crowd 3 trials or 3 experiments and get an average. If you want, we ask you the reason why you're doing it to get sufficient data so that your work is more valid. Yeah, and that will be the end for the first part that they ask you, the independent variable. Then, number 2, they give you a bullet. Talk about the dependent variable. As well, it has an element of identifying. Remember, dependent is what you measure at the end of the experiment. You want to find out how the independent affects your dependent. So at 0, how long will it take for diffusion to occur? So rate of diffusion becomes dependent. However, please note, you can never say rate of diffusion or rate of anything as your dependent variable. This answer would be wrong. Ask yourself, this value must be what exactly you can measure. Can you measure rate of reaction in an experiment? You cannot. A rate is calculated. A rate is calculated. Yet for us, we want something you can measure. So in an experiment, if I want to find out how temperature affects rate of diffusion, that is how it may appear. But please use a lot of understanding. Ask yourself, so what will I be measuring exactly? I'll be measuring how long it takes for the water to gain the color of the tea. So time becomes your dependent variable. So that's where now the problem comes in from being specific. It must be something you can measure at the end of the day. Maybe it's time, anything. So that dependent variable must be what you can measure, not what you calculate, because rate is calculated. Yeah. So identify it. Make sure when identifying it, it's something that you can measure. That's the most important thing. And that's all about that dependent variable. Okay, allow me to wrap off this. Hope you're writing down. Then number 3, when you leave the dependent variable, there's something else that you must know as well. That's called control variables. Control variables. Now, in an experiment, there are other factors. If they change, the experiment will be affected. For example, if I'm investigating how temperature affects rate of diffusion, there are things, if they change in the experiment, your results are going to become wrong. Can you guess? Just pick one. What do you think could change in my experiment that could affect my results if I'm investigating how temperature affects rate of diffusion? That's right. The amount of water I'm using is very important. Because I'm varying temperature of water, but I must use the same amount of water. That's very important. That becomes a control variable whereby you must identify them. You just observe carefully and ask yourself, what can change and how can I keep it the same? That becomes a controlled variable. Normally identify them. For example, I've said here, our hours could be the amount of water. Now, even the word amount of water, we like saying it, but the word amount is wrong. We never, what does amount mean? So you must be specific. It is a liquid, kindly say the volume of the liquid. If you say amount, you are gone. Then, if it is a solid, or I say it's the mass. So the mass of the solid also matters. Our tea experiment on tea leaves, if I'm using tea leaves, for example, it must be that the tea leaves I'm using in each experiment must be having the same mass. This is also important, the mass of the tea leaves. Maybe the number of tea bags. Such are also important. Even the nature of the cup I'm using matters. Is it metallic or it is plastic? Because you know, one of them conducts, therefore the heat will blow to the surrounding, or it may come in. So, such you keep them constant. You keep them constant. That's a part of identifying. After identifying, they may ask you to describe how you really keep them constant. How part? So if it is a volume, how do you keep volume constant? By saying you will measure the same volume. You will measure the same volume. That's good. You are measuring, that's how you will do it. You measure the same volume. Yeah, it's a solid, you will have to weigh as a mass. You weigh this. So tell us how you will do it. How will you keep it constant? Now, normally at times on this question, they also bring in these aspects. They ask you, what additional equipments do you need? Additional equipments do you need? On these experiments, most of them normally have a drawing like this one right here. That means that from here, you have seen what they want, what they are using, but they're asking you, what do you think you will need that is not shown here? The trick for that normally depends on which experiment, which apparatus will you need or equipment will you need to keep the control variables the same. So now ask yourself, if it is volume, do you need? Please guess for me. If it is volume, what should you use as an apparatus? That's right. You will use a measuring cylinder. That's good. A measuring cylinder. It becomes an additional equipment you will use. Please note, we never use beakers to measure volumes. Never say beakers. Yes, beakers have values, but the beakers have a lot of error, so we don't use them. We normally use a measuring cylinder. We can use a burette, a pipette, etc. depending. If it is a solid, of course you need a weighing scale. An electric balance, weighing scale, whatever you want to say, you'll be good to go. Then, what if it was maybe time? If you're keeping time, you're giving the experiments the same amount of time. If that's the case, what would you need? You need a stop. Someone can call it a stopwatch. What you call them in your school is okay. You need that. If you're keeping temperature constant, for example, what will you need? You will need to call a water bath. You need a water bath and etc. So every time they ask you for additional equipment, think about the controlled variables for the experiment and ask yourself, what are you going to need to keep them the same for all experiments? That's very, very important. Allow me remove this as well as we continue to number 5. All right. Point number 5 right here. So after these variables, now there's something they call a control experiment. Or some people call it a standard experiment. Standard experiment. Not always asked because it doesn't normally apply in all experiments, but it applies in most. So if they ask you, what is a control experiment? The other one was control variable. What you keep the same, like factors in an experiment. This is a control experiment. What you must keep, no. You want to be sure that the factor you are investigating is the one affecting the results. You want to be sure that the factor you are investigating is the one affecting the results. For a control variable, you're going to crowd the same experiment, but normally the key thing is you remove the independent variable. It's the one you want to find out whether it affects your results. So what you do, repeat everything the right way, but this time round, remove the independent variable or replace it with something else. Let me think about an experiment that I would like to find out. If you want to find out the effect of what can I bring? Sleep? Maybe amount of sleep. On concentration. Would this work? Now, effect of gadgets, maybe. Laptops, what on concentration in class? You want to find out the effect of gadgets on concentration. All right. So, of course, it'll be varying how many hours someone spends on the gadgets vis-a-vis their concentration in class. So, for a controlled experiment, what you do, you still measure the concentration, but you don't give that person the gadget. You still want to see, you keep all other factors the same like you were doing. But then, this time around, don't give them a gadget. Maybe give them a board game. Or you can replace it or remove it. You can use something else. But removing is the best one. Give them no gadgets and see whether that will still affect their concentration. So if you find out that gadgets also affect concentration, then you need to know that the variable you're talking about is not the only factor affecting your results. But if the gadgets are removed and you don't get the results you were getting when the gadgets were there, then you will know that really gadgets have a very good effect. But this depends on the questions, as you will see. Maybe it is an acid, looking at maybe how acids can affect corrosion. What you do, you will use water and see whether the water will affect your results. Yeah. Then number 6, as we come to a close, they ask you what we call methodology. Methodology simply means the steps you will follow. Now, of course, these steps here, they are normally in the question. You can look at the question and you can tell the steps, or you look at how the equipments are arranged, and then you can tell what they were doing step by step. Mention only the key steps, not everything, but importantly, the key steps that you really feel they are very. Don't say, now get a beaker, put on the table. It's not very important. There are key steps you need to say, like you see an example. That's methodology, where you tell us the key steps, basically how you're arranging the equipment to get the results you want. Yeah. Then they can also ask you for number 7. These are normally called safety considerations. Safety considerations. What someone normally calls a risk assessment. As a scientist, before you carry out any experiment, there are things you must put into consideration. Then normally we talk about a hazard, we talk about a risk, and we talk about control or a precaution. In each experiment, think about what can cause danger. What can cause danger? In our previous experiment on effect of temperature on diffusion, of course, you're using hot water. Now the hot water becomes a hazard. Then because of the risk. Risk means the danger caused. What can the hot water do? It can burn you. Then finally, so how do you minimize it? How do you avoid it? How do you control it? Then it comes in things like being careful on how you handle the water. If it was an acid, acids are corrosive to your skin. Maybe you must put on gloves. You must put on goggles. Maybe you must handle with care. Now, salt. So you give a safety consideration that brings out the hazard, the risk, and the precaution. Acids can corrode the skin when they get in touch. Therefore, you wear gloves, wear protective gear. Maybe take caution as you are handling them. So these are the common things they normally ask you about. The other ones, I will talk about them in our next video that we will focus on the inquiring part of the Criterion B. So if quickly I can go back up here and show you something which we can do in the next few minutes. So the experiment was given to us here. Now, just to put you on board, they said the percentage of the mass of calcium carbonate can be determined using the following equipment. Of course, these are found in the bones. They were investigating that you can tell which animal has been killed if you have its bones, because we know how much calcium is normally found in each individual animal. Now they have designed the experiment, and they will say, design experiment. In your answer, include the following. I advise you also give your points following the bullets given to you. Now they said a list of any additional equipment that you will need. Now here you think, what are my controlled variables? How can I keep them the same? If I come here, just to give you a hint of what the experiment was all about because of time, they were measuring basically how much carbon dioxide is produced when you react the calcium carbonate in the bonds with an acid. So you discover that in this experiment, you must be measuring the same amount of calcium carbonate or the bonds. Therefore, you need a weighing scale to be then. So you just mention weighing scale, comma. Of course, there is a liquid you are putting here, which is an acid. Therefore, you will need to use a measuring cylinder. That becomes an additional equipment. That is how you mention it, and you're done. Of course, I began from the middle, but it begins all the way from up for you to understand the question. Then they talked about provide details of your method of manipulating the variables. Talk about how the variables will be manipulated. Now here, you pick out the independent and you mention them. Here, the independent was basically the mass of calcium carbonate. And we said you must be using 5 different values. They were investigating about different animals. So what you will say, you will obtain bonds from 5 different animals. Be specific. Tell us a lion, maybe a dog, maybe a cat. Mention 5 of them of your choice. It's okay. There are 5 of them. For each of them, weigh the same mass, the same mass of the bonds. Okay, so that's how you are controlling the variables. Now you are weighing using a weighing scale. Can tell us what are you using? That's called manipulating, by telling us the equipment you are using to measure that thing. That will be basically for the dependent variable, how you're doing it. Then for independent. For the dependent, we're measuring the mass, the volume of carbon dioxide produced. So that means you will be telling us here that at the end of the experiment, you will measure the volume of carbon dioxide produced from the gas syringe. It's as simple as that. Yeah, that's all you will say there. Then, because it's a method, they want you to give a step by step. Look at it here and tell us, what do you think can be done step by step? What will you begin with? Of course, maybe you will put a given mass of the bonds to the conical flask. You will add a given volume of the acid into the conical flask. Then you will set it up. Then you will give it time for it to be fully complete, where you no longer see any bubbles coming from the beaker. This is a conical flask actually. Then when it has stopped, you measure the volume of the gas produced and record down. As simple as that, and you're done. There is nothing more to it. Then we ask another detail here. Details of the data you will collect. What are you collecting? Be sure to give us what are you collecting. We are collecting the volume of carbon dioxide produced. Remember, we shall be collecting the volume of carbon dioxide produced for each animal, but 3 times, and you are getting a mean. So you tell us such kind of things in your own language. It doesn't matter as long as they come up. Then, how will you use your data to decide which tooth or bone contains the most carbonate? Now you are evaluating. So you see, you're using bones of the same mass of different animals. You are measuring the amount of carbon dioxide. So how will you tell which animal had the highest calcium carbonate? It is simple. You can tell by basing on which experiment or which animal or which bone produced the highest amount of carbon dioxide. So you are basing on the amount of carbon dioxide produced. Where you have more carbon dioxide, it implies that bone was coming from an animal that had the highest amount of calcium carbonate. So you follow them as they are. Then you say a statement of any assumptions you made. Now, at times they say, how can you improve the experiment? What are the limitations? That's the idea. Now, assumptions. Ask yourself here, where could an error come from? Where we are sure that error will not happen. Normally, you observe. Look at the dependent variable you're measuring. You're measuring volume. Can the volume escape? By the time you come and put the cork and the gas syringe, don't you think part of the gas would have escaped? The answer is definitely yes. Therefore, that becomes an assumption. You are assuming that no gas will be lost, but ideally, that is impossible. By the time you connect here, part of the gas will have been lost. That becomes an assumption. Now, these, you just have to observe them and get used to them. Yeah, but shall practice them with time. Then also, how will you ensure that your method is safe? Now, that part for safety, what we call safety considerations. Ask yourself here, what is the hazard, the risk, and the precaution? Yet they are using an acid. Someone will ask, but teacher, where are you getting acid from? If you come back up here, they talk about an acid. Yeah, that's what I'm already aware. They talk about an acid. Acids are corrosive, they burn. What do you do? Wear gloves, wear goggles, handle with care. Such is how it's done. So, thank you for listening to me. That is how planning an investigation is done. The things may be familiar or unfamiliar. What matters is simple, always following what they are saying and having what you must talk about in your own language to always come out. Now, there is a link below within this video. Kindly tap on it and then it will give you a question for you to attempt. When you attempt it, I will be able to give you feedback. It's a Google form on an example of a question that calls for planning and investigation. Thank you for listening to me. See you in our next video.